Hi guys, this is organic nomenclature and we are naming alcohols. So the general formula of alcohol is ROH, where R stands for an alkyl group, and comparing carbon, nitrogen, or hydrogen, actually not nitrogen, carbon, hydrogen, and oxygen, the general formula becomes CnH2n plus 1 OH, OH being the functional group for alcohols, and the name of alcohols. If we start with the alcohol with one carbon atom, which would be CH3OH, the name would be methanol. With two carbon atoms, it would be CH3, CH2OH, and it would be called ethanol. With three carbon atoms, CH3, CH2, CH2OH. This should be called propanol, but we will call it propane 1-all. Reason being, here we have different positions where the OH group can be placed. So in this compound, the OH group was placed at the terminal carbon atom. So that was the first position. So propane 1-all. If we have the same alcohol with the CH2 becoming CH and the OH being placed on it and CH3 on both the terminal positions, the name of this alcohol would become, according to the numbering, propane 2-all. Now let's combine different functional groups and substitute groups. So the different functional group here, let's use halogen and an alcohol group and an alkyl group. So we have CH3, CH, we would place OH here. We would have another CH with a Cl placed here and a CH with a CH3 placed here and then another CH3. So in total, we've got five carbon atoms in the longest parent carbon chain. Now, preference would be given to the OH functional group, obviously, because it is the functional group here. So the numbering would be done from left to right, 1, 2, 3, 4, 5. But the name would be written with the alphabetical preference for the substitute groups. So the name of this compound would be 3 chloro 4 methyl. The parent compound contains 5 carbon atoms, so pentane. We do not use the last letter E. Instead, we write the number of the position of the OH group, pentane 2 all. So this is how we name alcohols along with the substitute groups. So using more examples, we would have CH3, C, then we would have another CH3, we would have a CH3 placed on top and an OH group placed at the bottom. So the numbering would be 1, 2, 3, and the name would become 2-methyl propane 2 all. Another example, CH3, C CH3 with chlorine at one end and OH at the other. Numbering would be 1, 2, and 3. The name would be 2-chloropropane 2 all. In organic compounds in which there are multiple OH groups present, the naming would be done in a different way. So let's use a compound in which we have one OH placed in a compound having three carbon atoms. The other one would be one in which we've got two OH groups placed in a compound having three carbon atoms. And the third one would be a compound in which we would have three OH groups placed in a compound having three carbon atoms. So we've got multiple OH groups present in the same length of carbon chains. So the naming of the compound would obviously be starting from the position of the OH group. So in this case, 1, 2, 3. Numbering would be done this way, and the name would be propane 1 all. In the case of the second compound, we have 1, 2, and 3. The name would be propane, PROPAN. Now we will not omit the alphabet E. We would write the complete name propane. Then we would place a hyphen. We would put in the position of both the OH groups. So it would be 1, comma 2. And then since there are two OH groups, one OH group is referred to as all, two OH groups would be referred to as diol. And in the case of the third one, the numbering doesn't matter. We start from left to right or right to left. So 1, 2, and 3. The name of the parent compound would be propane, written completely with the positions defined as 1, 2, and 3. And the name of the functional group, because there are three of them, would be called triol. So now we would have compounds having multiple OH groups in combination with substitute groups. So CH3, CH, 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 and then CH3. I would place an OH group here, NOH group here, and a methyl group here. So the name of this compound would become, numbering from either side, the OH groups will get the positions of 1 and 4. So 1, 2, 3, 4, and 5. 5 carbon uh, parent compound would be called pentane. And since there is a substitute group present on the third position, which is methyl, the name of this compound would be 3-methyl pentane, written completely. Positions of the OH group defined 2, comma 4 diol. Another compound would be CH3, C, CH, CH, CH3. We have a methyl group placed at one end and OH group placed on the other, with an OH group placed on the adjacent carbon atom and a chlorine atom placed on the adjacent carbon atom to the one with the OH in the middle. So the name of this compound would be, first the numbering would start from left to right because the OH group and the methyl group would be given preference. Two substitutions on the same carbon atom. So 1, 2, 3, 4, and 5. So the name of this compound, now we need to consider the alphabetical order as well. So on the second position, we've got a methyl group, and on the fourth position, we've got a chloro group. So 4 chloro, 2 methyl, then we've got a 5 carbon compound, so pentane, name written completely, positions defined 2, comma 3, and then we write diol. Since the functional group for alcohols is the OH group, we also need to know that the OH group can act as a substitute group. And this is only possible if there is another functional group present in our parent compound. So let's take a carboxylic acid. The naming of carboxylic acids would be as covered in the topic carboxylic acid. So we have a COOH group here. Then we have a carbon atom. Let's place a hydrogen here, an OH group here, and a CH3 group here. So the rule for naming carboxylic acids is that the COOH carbon is always the first carbon atom. So we don't have a choice in numbering. So 1, 2, and 3. However, the parent compound contains three carbon atoms, and the substituted group placed at the second position is the OH group. So now, since the OH group is acting as a substitute group because the functional group here is the carboxylic group, so the name of the substitute group would be called hydroxy. So the name of this compound would be 2-hydroxy, and 3 carbon carboxylic acid would be called propanoic acid. In a similar way, if we have a combination of multiple substitute groups present on a carboxylic acid, so let's make that structure COOH. We've got C, we've got another C, and then we've got a CH3 placed here. So CH, and we've got OH here, we've got CH3 here, and we've got Cl here. So the numbering is fixed. Numbering would be done from right to left, 1, 2, 3, 4. So the only uh, way we can name this compound is giving alphabetical preference to the substitute group. So there are three substitute groups here. We have a methyl group M, a hydroxy group H, and a chloro group C. So alphabetically, C comes before H and H comes before M. So the name of this compound would become 2 chloro 3 hydroxy. Then we would have uh, 3 methyl as well. And the name of the parent compound containing 4 carbon atoms would be butanoic acid.